In this video, we'll be discussing arc length. The length s of an arc intercepted on a circle of radius r by a central angle of measure theta is given by s equals r times theta, where theta is in radian. So this is like the piece of the crust of the pie I always think of arc length. So let's find the arc length when our radius is 12 centimeters and our theta is pi over 2. Our definition says that our theta has to be in radian, so if it's not given in radian, be sure to convert it right away. Ours is OS, our arc length, is going to be equal to 12 times pi over 2. So this is going to give us 6 pi, and our unit is centimeters, since this is a linear measurement. Let's look at an application problem. Halifax, Nova Scotia is approximately due north of Buenos Aires, Argentina. The latitude of Halifax is 45 degrees north, while that of Buenos Aires is 34 degrees south. The radius of the Earth is 6,400 kilometers. Find the north-south distance between the two cities. We'll round to the nearest tenth. So I'm going to start with a picture. Draw our Earth. And they give us these latitudes, and latitudes are based from the center of the Earth and the equator. So here's the center of our Earth. If Halifax is 45 degrees north, that means from the equator, we want to go 45 degrees right here. And Buenos Aires is 34 degrees south, so from the equator, we're going to go south 34 degrees. And we're trying to find the distance in between. So we're trying to find this arc length right here. So that means this whole thing is going to be our central angle theta. So theta is going to be equal to 45 plus 34. It's going to be equal to 79 degrees. All right, so that's our theta, but in order to put it in our formula, our theta has to be in radian measure. So right away, we want to convert that. Multiplying by our unit fraction of pi over 180. This doesn't simplify, so I'm just going to leave it in its exact form, 79 pi over 180. And then our arc length formula is our radius times theta, and they told us that the radius of the Earth is 6,400, so let's multiply that by 79 pi over 180. I just plugged this whole thing in my calculator at once, and then we're rounding to the nearest tenth. 8,824.4, and our unit is kilometers. In these last two examples, we've found the arc length, but we can use our arc length formula to find things other than s. So in this next example, we want to find the central angle theta in radian measure, given that the radius is 10 feet and the arc length is 30 feet. Well, we're using our arc length formula, s equals r theta, so we just plug in 30 equals 10 times theta, dividing both sides by 10, we get theta to be 3. And this is radian. Since you have to convert to radian to plug in to our arc length formula, anytime it spits out an angle, it's spitting out a radian measure. And let's find the length of the radius given an arc length of 10 millimeters and a central angle of 2 degrees. Our arc length formula only works if we're in radian, so right away let's convert our degree measure to radian. So 2 times pi over 180 gives us that theta is going to be pi over 90 radian. And now plugging into our S equals R times theta formula, we get 10 is equal to R times pi over 90. So let's divide both sides by pi over 90, or think of it as multiplying by the reciprocal. And we're going to get that R is equal to 900 over pi. And this is our radius, so it gets a unit of millimeters.